Howdy! This is your friendly neighborhood physics teacher here, and happy 2019! So, we have our first video of 2019, and it's a complete review video over forces at an angle. I'm not exactly going to just do practice problems. You did practice problems in class, but what I'm going to do is I'm going to go over kind of the different steps you could use, the different ways you can do it, hopefully helpful hints for you to solve these problems. So the first thing you have to remember is when you draw a force, when you see a force at an angle, so if this is, say, we'll just do force 1, and it's at an angle, you're going to end up making a triangle. So this will end up being your force 1x, and this will end up being your force 2x. So you have to make a triangle. And then you will have to use sine, cosine, or tangent. This side is your hypotenuse. If this is your angle, this will be your opposite, and this is your adjacent. At that point in time, you decide if you're using sine, cosine, or tangent. For your, which that didn't even look like a y, for your f2y, you're going to end up using sine. And this should be f1. This is y. There we go. f1y, because it's the force of 1y. You'll end up using sine. And so it'll be hypotenuse, sine, theta. For your f1x, you'll end up using cosine, theta. And you would work it out. Now, if you have a force at an angle and then one that is not at an angle, how many forces at an angle do we have? 1. How many triangles should you be drawing? 1. So you'll have force of x and then force of y. Force 1, because this is force 1, so if this is force 2 equals your f2x, and your force to y is going to be 0 because it's not moving in the y. It's only in the x direction. You only have to do sine and cosine if you see an angle. And then if you have 2 at an angle, if you have 2 at an angle, then you have to do 2 sine and cosines. F1x, you have f1y, f2y, and then you have f2x. So you have to do both. And again, you'd go back here and use sine and cosine. So you'd end up doing it 4 times. Now, once you do that for any problem, then you have to think about your adding and subtracting. So you would decide using your net. So if you're doing your net force, and this would be your net force or your resultant force in the y direction, you would add up all the forces in the y direction. Remember, y is up and down. And then you would do your resultant force in the x direction. Remember, x is horizontal. If your forces are going in the same direction, you add. If your forces are going in opposite directions, you subtract. Well, honestly, you are adding, just that one going down would be negative. And it's the same thing for your x. If they're going in the same direction, you add. If they're going in opposite directions, that one going to the left would be negative. After you do that, you would end up having to do a triangle. because this is, again, R and X. So you would draw your X first. So this would be your F, R, X. Always draw your X first. Then you would draw your Y, F, R, Y. And that makes a 90-degree angle because it's going straight horizontal and straight vertical. And then that's when you would draw your hypotenuse. Your hypotenuse always goes from where you started to where you're finished. And that would be your force, resultant force. And then you would also need to find your angle. To solve for your resultant force, you would just be doing Pythagorean theorem. So you'd just be doing a squared plus b squared equals c squared. It doesn't matter which one's a or b, but your c has to be your fr. So, and that's what you're looking for. So you just do frx squared plus fry squared. That would end up equaling your fr squared. To get rid of the square, you square root both sides. You do fr equals the square root of frx plus your fry squared. And you would solve for that. Now, if you're looking for your angle, so we'd have to be looking for our angle. If we're looking for our angle, whoops, is that really big? You would end up doing your inverse. You'd be doing your inverse. So you would have, in this case, you would do your inverse tan. And so for your inverse tan, again, this is, whoops, moved around. This would be your opposite. This would be your adjacent. And this would be your hypotenuse. So tangent is opposite over adjacent. So you would just plug in for inverse tan. You would just plug in fry over frx. And there we go. And that's how you find your angle. Now, it's according which direction it's going if that angle stays the same. Because you have to remember, you have to go back to your quadrants. So going to your quadrants, you have 0, 90, 180, 270, and 360. Now this is why I say always draw your horizontal first, because if you're always going to end up being on either of these sides. So if your direction is northeast, you don't have to do anything. Okay? So it's the same, you're done. If you're having to go northwest, so this would end up being your angle there, you would have to subtract. You'd have to subtract from 180, your theta from 180. If you're going down here, you would add 180 to your theta. And if you're going down here, you would end up subtracting 360 from your theta. And that's to find the correct direction for your theta. And that's basically knowing if you're going northeast, northwest, southeast, southwest. So again, I didn't do practice problems. We did practice problems in class, so hopefully you took notes. This is kind of like a little step-by-step on what you do. So remember, you have to make a triangle, and you're doing your sine and cosine. And then you have to, and it's just, you only have to do the amount that's given. So there's only one angle, you only have to do one sine or cosine. If there's two, you got to do two sines or cosines. And then you would add up all your y's, add up all your x's. Direction matters. Remember, going down is negative, going left is negative. And then you would have to do another triangle, draw your horizontal first, and draw your vertical, have your hypotenuse, use Pythagorean theorem to solve for your force of resultant force, and then use your inverse tan, or you can use any sine or cosine. I just tend to use inverse tan to solve for your angle, and then you have to see where it actually is on your unit circle. If it's in the quadrant 1, it's done. You don't have to do anything. If it's in quadrant 2, subtract from 180. Quadrant 3, add from 180. Quadrant 4, subtract from 360. Now, it's very quick, brief, and hopefully that helps. If you have any questions, please let Miss Heath or Miss Verona know. Have a wonderful day. Bye!